Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at turning and inflection points of cubics. So previously we've graphed cubics whilst ignoring turning and inflection points, but now we will calculate them. But in order to do that, it's important we know what they are. So turning points are where the graph stops and turns around. They can be maximum turning points or minimum turning points. So inflection points, as I've discussed before, signal a change in concavity. It's where a graph goes from being concave up to concave down or vice versa. So here is an example of a stationary point. The graph goes from being concave down, frowny face, to concave up, which is a smiley face. Now, inflection points are always halfway between turning points. So we could find this point easily if we knew the coordinates of the turning points. So inflection points basically come in two types. They can be stationary, which means they're flat. We've seen these when we did transformations of cubics, but there can also be non-stationary inflection points. So at this point here, just like this point here, there is a change in concavity. Here we go from smiley face to frowny face, but the graph isn't flat at this point. It's still, in this case, increasing. So we're going to look at how to find such points. So the inflection point of a cubic, whose equation can be written like this, is always negative b over 3a. Now to find the turning points, you need to solve this equation here. All right, let's put this to work and graph this function here. So for y equals x cubed plus 3x squared, we still want to find the x and y intercepts. So the y-intercept is just the constant term, so it's 0. To find the x-intercepts, we still do what we did previously. We want to factorize the cubic. So highest common factor is x squared, and then we have x plus 3. So there is a double root at x equals 0, and there is a single root at x equals minus 3. So none of that is new. We've been doing that. What is new? We're going to calculate the coordinates of the inflection point and the turning points. So let's start with the turning points. So we want to solve this equation here. Now in our original expression, we had a is equal to 1, that's the coefficient of x cubed, b is equal to 3, that's the coefficient of x squared, and c is equal to 0. So in order to find the turning points, I want to solve 3 times a times x squared plus 2 times b times x plus c equals 0. We want to solve the equation 3x squared plus 6x is equal to 0. So again, of course, we can factorize. We get x equals 0, that's 1, and the other is x equals negative 2. So we knew that x equals 0 would be a turning point because it's a double root. Double roots always are turning points. They bounce off the axis either this way or that way. So we've also found that x equals negative 2 is a turning point. So if x equals negative 2, what's the y value? We just substitute it here. The y value is negative 2 cubed, which is negative 8, plus 3 times negative 2 squared, it is positive 4. So we know that there is going to be a turning point up here at negative 2, 4. We also know that there is a double root here, there is a single root here, and of course we know that the y-intercept is there. Now notice here that a, the coefficient of x cubed, is positive, so it's going to be top right, bottom left. We know what the graph is going to look like. It's going to come up through here, go through x is negative 3. That was a single root. The turning point's at negative 2, 4. Then it's going to stop and come here. We know that the origin is another turning point, so it's going to go up forever in the distance. So that's what the graph will look like, but where is the inflection point? Well, cubics always have one and only one inflection point, and if you have 2 turning points, it's always halfway between them. So we know it's going to occur here at x equals -1, because that's halfway between -2 and 0. But we can also use this formula here. X equals -b, so b is 3, over 3 times a. A was 1. It occurs at x equals -1. Now, when x equals -1, I want to know the y value. How do I determine that? I substitute in here. I just get -1 plus 3, which is 2. So there is an inflection point here at -1, 2, that point there. So that is where the graph changes, in this case, from being frowny face to being a smiley face. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.